Okay, so in this example, we want to find the tangent line to f of x, which is equal to 15 minus 2x squared, which is at x equals 1. Okay, so let's go ahead and graph this curve on Desmos. So I've graphed this curve. You can see that my viewing rectangle goes from -1 to 3, and then from -4 up to 20. So let's go ahead and graph the curve here. So this is 15 minus 2x squared. Okay, so here is our curve. And so we want to take a look at the value at 1. So at 1, what is this point here? Well, this point at 1 is 113. So I'm going to go ahead and I'm going to plot that point here. So I'm going to put 1 and then 13. Okay, so there's 1 point on the graph. Okay, now we're going to pick another point. So another point that we can see on the graph here is at 2, see here, it's 2, 7. Okay, so let's go ahead and put that point in, 2, 7. Okay, and then we're going to go ahead and label that point. Okay, so we have 1, 13, and then 2, 7. Now, let's go ahead and then create that line here. So we're going to go ahead and draw a line so we can see what the line is there. Okay, so here what we've done is we have a curve and we want to find a tangent line to this curve at x is equal to 1, where this point is. So we want to find a tangent line that's going through there. But right now we can see that this represents a secant line. And remember, the tangent line has to be parallel to that point. And currently, right now, it is not. So let's take a look at what this graph looks like. Okay, so here we can see that, again, here is our curve. We know that the point that connects 113 and 27 is the secant line, and this represents the tangent line. Now, we can see that from this graph at the secant and the tangent lines are somewhat similar. And so the slope of the secant line should be somewhat close to the actual slope of the tangent line. So as an estimate of the slope of the tangent line, we can use the slope of the secant line, and we're going to call it m with a subscript of pq because we're finding the slope of pq, which is the following. Okay, so we want to find the slope of pq. Well, we're going to take f of 2, which is the output for 2, minus f of 1, which is the output for 1, over 2 minus 1. Well, if we look at that, we know find the slope, we're going to take the value of 7, and then subtract 13, and divide that by 2 minus 1, which is 1, which gives us a slope of -6. So now, we can say that, okay, if we weren't too interested in accuracy, we could say that this is good enough and then use this as an estimate of the slope of the tangent line. However, we would like an estimate that is at least somewhat close to the actual value. So to get a better estimate, we can take an x that is closer to x is equal to 1 and redo the work above to get a new estimate on the slope. We can then take a third value of x even closer yet and get an even better estimate. So in other words, as we take q closer and closer to p, the slope of the secant line connecting q and p should be getting closer and closer to the slope of the tangent line. So let's take a look of a graph that shows as q is getting closer to p. Okay, so here we can see that this is getting closer and closer to p. And so we can see that the exact slope up here is actually -4. So as this point starts traveling closer, you can see here as we're getting closer and closer to 1 here, right, we can see that the slope is getting to -4. So again, as you can see, we move Q in closer and closer to P. The secant lines does start to look more and more like the tangent line. And so the approximate slopes, i.e. the slopes of the secant lines, are getting closer and closer to the exact slope. Also, do not worry about how I got the exact and approximate slopes. We'll be computing the approximate slope shortly, and we'll be able to compute the exact slope in a few sections. Now in this figure, we only looked at Q's that were to the right of P, but we could have just as easily used Q's that were to the left of P, and we could have received the same results. In fact, we should always take a look at Q's that are on both sides of P. In this case, the same thing is happening on both sides of the point P. However, we will eventually see that that doesn't have to happen. Therefore, we should always take a look at what is happening on both sides of the point in question when doing this kind of process. So, let's see if we can come up with the approximate slopes we showed above, and hence an estimation of the slope of the tangent line. In order to simplify the process a little, let's get a formula for the slope of the line between P and Q, which is m subscript PQ, that will work for any x that we choose to work with. We can get a formula by finding the slope between P and Q using the general form of Q is equal to x f of x. So let's go ahead and do that. Okay, so we have our points. Our first point is 1, 13, which is what we're dealing with here. And then we're going to use a point Q, and we're going to call that x and then f of x. Okay, so we want to find the slope of PQ. So what that means is we're going to take f of x being y1 at y2 and subtract 13 all over x minus 1. Well, if we go back to the problem, what does f of x represent? Well, f of x represents what? 15 minus 2x squared. So we know that f of x is equal to 15 minus 2x squared. So we have 15 minus 2x squared minus 13 over x minus 1. Now if we combine like terms, 15 minus 13 is going to give us 2 minus 2x squared all over x minus 1. So now what we've done is we've created a formula, and we just need to pick values of x. So what we can do is we can create a table using this function to figure out what those numbers are going to look like. So by using Desmos, okay, we're going to pick some values of x getting closer and closer to x equals 1, and then plug it in to get some of the. So let's go ahead and do that. So here we have our Desmos. Okay, we're going to create a table. And so our function that we have, or our formula here, is going to be, we have 2 minus 2x subscript 1, and that's squared. And then divided by x subscript 1 minus 1. Okay, so now what we're going to do is we have our point that's at 1. We're going to look at all the points are going from 2 to 1, and then the points on the left going from 0 to 1. So let's start with 2. So we get negative 6 as we had received there. And 1.5 is negative 5. 1.1, negative 4.2, 1.01, 1.001, and then 1.0001. Well, you can see here that the slope is getting closer and closer to negative 4. Now, let's go from 0 to 1 now. So we're going to plug in 0. We get a slope of negative 2. 0.5, we get negative 3. 0.9, negative 3.8. 0.99, negative 3.98, 0.99, negative 3.998, and then 0.9999. So you can see that it's getting closer and closer to 4. So as you can see, that's what's happening with our particular values. So here, let's take a look at the table here. So here's our table. So we can see that when we plugged in x that went from the right, from 2 to 1, we got negative 4 here, and then over here from 0 to 0.99, we also got negative 4. So if we take, again, the x's to the right of 1 and move them in very close to 1, it appears the slope of the secant line appears to be approaching negative 4. And likewise, if we take x's to the left of 1 and move them in very close to 1, the slope of the secant lines again appears to be approaching negative 4. So based on this evidence, it seems that the slopes of the secant lines are approaching negative 4 as we move in towards x equals 1. So we will estimate that the slope of the tangent line is also negative 4. And so as noted above, this is the correct value, and we will be able to prove this eventually. Now the equation of the line that goes through the value of the point at xa, which is a f of a, is then given by the following equation. We're using the point slope form. So remember, that's y minus y1, which is equal to m times x minus x1. And in this case, we're using the point A. So this becomes y minus f of a, which is equal to m times x minus a. And so we would use the point slope form. So now going back to the question of what it's asking us, we want to be able to find the equation of the tangent line to f of x is equal to 15 minus 2x squared at x equals 1. And we know that that point was 113 that we needed to use. Okay, so we're going to plug that into our form. We know that this becomes y minus f of a, which is 13, which is equal to the slope, and we found the slope to be negative 4 times x minus 1. And now let's solve for y. So we have y minus 13, which is equal to negative 4x plus 4. And if we add 13 to both sides, we're going to get negative 4x plus 17. And so therefore, that is the equation of the line that is tangent to that curve. And let's just make sure we can see that on Desmos. So let's go ahead and graph the equation, negative 4x plus 17. Well, therefore, now we can see, and I'm going to go ahead and copy that here. So now we can see that the graph of y, which is equal to negative 4x plus 17, is tangent to that curve.